But I put this app up on Google Play Store. It's a math education app. And if you search for it in the Google Play Store, you search Broad Fork, the company name, and then it really narrows it down to a few apps. I don't know why you can't search by app name, but you can't. So, and then you'll see Math Time, or you'll see one of the color schemes, or something that looks like one of these screens on there. Google Play Store, and it's free. And one time I had it up on Apple iTunes, but they were a nuisance. And but a teacher did give me a nice review. She said she had an advanced placement class, she or he, I don't remember, and middle school or high school, I don't remember, and said that it was the best lesson of the year, that it kept the students well occupied and going through the lessons for the hour. So it could be used on 1 day, 2 days, or even more. But so let me go to the menu. I'll put this video up on my YouTube channel, and if I figure out the screen recording software later, I'll maybe redo it. Time clock for real young kids, or even for middle school kids, and 24-hour clock is what we use on here on the app. And then angle measure, and then circle geometry. Number 4 is supposed to say trigonometry, and that is the first time I've noticed that mistake. Number 5, Pythagorean Theorem. But real simple instructions, and let me show you. So first angle measure is here. These headings are called out. The only one that's not up here is time clock, but that's right here on the circle. So then it's time clock, angle measure, circle geometry, trigonometry, and Pythagorean theorem. So you grab the bird. Oh, this is a sign of the time, was the old title. We're looking down on the Earth from above the North Pole. This is just to indicate that the sun, ray of the sun going through the middle of the Earth. It's a baseline in this diagram. Excuse me. So angle measure, yeah. So the angle measure is called out at the top of the page. You can see it. I use radians because radians are constructed actually from the way a circle is built. If you take one radius and lay it on the circumference of the circle, one radius laid on the circumference of the circle, the angle that's created is 1 radian. And the equivalents are down here for gons, radians, and degrees, down at the bottom left. So then you can play with that for a while. When you sun up, and then sun's overhead, and then near sunset, 1700 hours, 1800 hours, as they say in military time, and then up to 24 hours, and you start over again. So then the next one is circle geometry. Pi r squared is area of a circle, or parts thereof is just whatever portion of pi r squared. And then arc length is 2 pi r, or whatever portion, it was the whole circumference, whatever portion of the circumference you're measuring, correspondent with the angle that you're turning. So then the next one is trigonometry. I just put up here the sign. You can see the other 6 basic trigonometric functions are easy enough to find the equation. So it's opposite, as I say, over radius, or y over r. And so for any given angle, here it's 0.9 r. The opposite over the radius, it gives you a sine value for that angle of 0.78. And here's the graph of the sine and the cosine moving along, the values moving along as the angle is turned. And of course, the angle is also directly tied to because it's about the angle measure, and it's about the relationship between two sides of the right triangle as the angle is turned. Again, sine is opposite over hypotenuse. Cosine adjacent over hypotenuse, as I say. So then we go to Pythagorean Theorem, which was just convenient to put it on here because involves the right triangle. Square of the x side and plus square of the y side is the square of the radius. So those lengths are known in this app, so I just put it on there. So let me go back to the menu real quick. I have the graphs for the just a fixed static graph of the 6 trigonometric functions, 6 basic functions: sine, cosecant, cosine, secant, and tangent, cotangent. And then, splash screen. I used to call it sine at the time, and I still like that name, so I kept it on the splash screen. Okay, I want to show something else, but I'll do it on a whiteboard, and I'll attach it to this video. I guess degrees were developed when we used back in the base 60 number system was used. Now we always use a base 10 number system. And but I also was one day playing with base 2, and while radians are found using the way a circle is constructed, and it seems like degrees and gons are rather arbitrary, I did find a relationship of gons to the radian, using the base 2 number system, and I guess it was just a coincidence, but I found it novel, so I'll show it on the whiteboard in a minute. So anyway, search Broad Fork in the Google Play Store, and it's free. Oh yeah, you can also click up here at the top right, hit clock, and it'll go to the current time. I guess it's tied into the smartphone or laptop in this case. And then you just, the clock turns off, I guess, when you grab the bird and start turning it again manually. Okay, that's it. So let me hit pause here. The area of a sector of a circle, whichever portion you want to measure, is 1/2 the angle turned times the radius squared. That is sector area. Now, we saw the area of a circle, we always say, is pi r squared. It's just because when you do the whole circle, it simplifies to this. Okay. So anyway, so it's 1/2 of the angle turned. I turned the angle, on my app, I put angle in radius. Sector area. So just because I wanted to focus on radians, right? Radians, did I say that right? The angle in radians. In the app, I just wanted to focus on radians. But, you know, on the app, I give the equivalency in the lower left of gons and, or grads, as they're also called, in degrees. Okay. So anyway, I was mucking around with the base 2 number system, and I realized that the closest approximation of pi in the base 2 is 3 1/8. That's what that is. in base 2. It's 3 1/8. And then I was trying to figure out a way to break up radians using the binary number system into something that was usable. And so I said halves. No, that wasn't any good, because in base 2, this just to the right of the, it's not a decimal point, it's a binary point here, but it wasn't practical. And force, no. Let me zero out the column. No, that's not enough. Excuse me, I wasn't even going that way anyway. I was going the other way. Ones, no. 1 radian is too big of an area to do anything with. Into 2 pieces, no. 4 pieces, no. 8 pieces, no. 16 pieces, no. 32 pieces, no. 64 pieces, that's that column in base 2. And I thought, yeah, that's good. 64 pieces. So 64 in base 2 is 1 and 1, 2, 3, 4, 5, 6 zeros. So I put 1, 2, 3, 4, 5, 6. Did the multiplication, and I came up with 200, which in base 2 is going to be fill in the 128 position once, fill in the 64 position once, and then nothing in the 32 position, nothing in the 16 position, 1 in the 8 position, and none in the 4 position, none in the 2 column, I should say, and none in the 1 column. So that, now this is used approximation of pi in the base 2 number system. The usable approximation is you take all the following digits, because you know pi is an irrational number. It goes on forever after the point, binary point or decimal point. So this number, of course, in base 10 we use as 3.14, but it goes on forever. We rationalize it just so we could use it, but the rationalization is only an approximation. If you're doing an iterative process, you use as many digits after the decimal point or binary point as you can get into your computer. Of course, interestingly, in the base 2 system, it never sets up a repeating pattern after the binary point. Just like pi, it's irrational, never sets up a repeating pattern after the decimal point. So anyway, that come out to 200, which just happens to be the number of gons, in this case, in a half circle. And I don't know why it comes out that way, but that is in fact how many gons there are in a half circle. Okay, that was that novelty.